other parts of the organization. Now, if change is not managed properly, and by managed I don't mean slowed down, but I mean properly managed so that all of the implications of a change are taken into account, the changes will impose a number of inefficiencies on testing. Now, another challenge that we've seen with our clients who are doing Agile is a challenge of trying to remain effective during the very short iterations that we tend to see with Agile. So you think of a sequential life cycle model, and you know, the sequential life cycle models they tend to have a long period of time where we can develop and maintain tests, but that's assuming, of course, that you actually do get to engage early, and not all of the organizations that are doing sequential life cycles by any means do that. But assuming that you could, then you could engage early as the test team, and they'd have a long period to develop and maintain tests prior to test execution. Now, even certain iterative life cycle models, such as, for example, RUP, do allow fairly substantial periods of time between iterations, and thus that allows time for the testers to develop and maintain tests in those interim periods. Now, Agile methodologies tend to move much faster. You see these 2 to 4 week type of turnaround times, and that's you know, for these iterations, and then that puts a lot of squeeze on the test team's ability to maintain their tests, to develop the tests. Certainly, maintainability, especially of the automated tests, is a very big consideration, and this is another reason why I emphasized before. You know, think about how to maintain those automated tests, because you can get to a point where you're falling further and further behind. Now, risk-based testing strategies are definitely helpful in these situations. Anytime you're time compressed, risk-based testing is a great idea because it allows you to transparently and with the consensus of the team make decisions about what should be tested, how much, in what order, and conversely what should not be tested. And you know, this test triage, if you will, becomes a very important thing in these iterative worlds. Excuse me. There we go. Sorry about that. Now, hopefully your screens are going to catch up here. I just had, for those of you who haven't seen that, it dropped out of presentation mode, but I'm back in now, and I believe all of your screens are refreshed. Now, this brings us to another challenge, which is the inconsistent or inadequate use of unit testing facilities. Now, the Agile methodologies, to my mind, great credit, do stress good automated unit testing, and so this is I think, a strength of the Agile methodologies. But we do see a couple problems. One is sort of a theoretical problem. Unit testing is good, but according to Capers-Jones's studies, it has fairly limited bug finding effectiveness. If you take a look at some of his books, like Estimating Software Costs, for example, you'll see that the average unit test effectiveness is somewhere around 25 to 30%. Now, in our studies, when we've done assessments with our clients around the world, we see that a good independent system test team tends to average about 85% defect detection effectiveness. So, you know, clearly you want to have both. If you've got a bug filter that is only going to catch a quarter of the bugs, we need to have another filter, and the system testing is something that you want. Now, the other problem is that not all the programmers, even in Agile worlds, do unit testing. And we've heard a number of different stories about why, you know, oh, that doesn't apply to my system, or my software's too tightly coupled to be able to do it, or whatever the rationalization, and it's always a mix of good reasons and rationalization. This creates a lot of problems. If the code is coming insufficient unit testing into system test, given that the sprints are already short in time compressing the test execution periods. Having code show up that is not stable and ready for very quick, effective system testing can do a lot of damage. You can get to a point where you're really not fully engaged in the testing as you're approaching the last day or so of the sprint. So it's very important that unit testing be done, and that people do as much of it as they can, work around challenges like coupling and so forth. But also people need to keep in mind that unit testing by itself is not going to be sufficient. Now, here's a challenge that is definitely inherent in any software engineering project following any life cycle model where there is a lot of change to the code. That is, I think, philosophically embedded in the Agile methodologies. It's perhaps something that happens in other projects where maybe it shouldn't, but in any project where you have a lot of change in the code, particularly in Agile life cycles where code is getting churned in each subsequent sprint by changes, you're going to have an increase in the risk of regression. It's unavoidable. I mean, good system design can help minimize that. You want to make sure that you don't have way for unforeseen implications to ripple through the system and cause a lot of regression problems. But the more you change, all things being equal, the more you risk upsetting the apple cart, as the saying goes, damaging something that currently works. Now, theoretically, in the Agile philosophies, as I understand them, this is one of the reasons why you see a lot of tools like JUnit and CPP unit and so forth in place to create automated unit test harnesses that will allow the programmer, upon changing the code, which you'll sometimes hear this phrase refactoring used to describe a restructuring or major revision of a piece of code. These unit test harnesses will then allow you to rerun all of your unit tests, and that's great, and I think that's very important. But again, I need to remember that there's limited bug finding effectiveness in unit tests. Even the most effective unit tests, again, according to Capers-Jones's studies, tend to top out at about 50% effectiveness. So we've got a 50-50 chance of catching a regression bug, roughly. So you are going to need effective regression testing that's happening at the system level after the regression testing that's happened at the unit level. Now, this is why I said that you need to have a maintainable automated regression test suite at the system test level. Risk-based testing alone is not going to be enough because the level of regression risk is going to be sufficiently high that you will probably be unable to stay on top of it. Okay. Now, here's another interesting challenge, and again, this is something that could happen even in any life cycle model, but there's a sort of inherent bias towards this in the Agile world. So the problem of the poor, changing, or missing test oracles. Now, a test oracle, just to be clear, is something or set of things that you can refer to in order to determine what correct behavior is. Now, a lot of times we think of, oh, that's the requirement specification, or, oh, those are the use cases. Well, one of the things that's in the Agile manifesto is a statement that you should value face-to-face conversation over heavy-duty, heavyweight specifications. Documentation is devalued in terms of Agile philosophy. And we've seen people, I guess you would say, take that to an extreme and provide so little documentation about what the system is supposed to do, so little information to the testers, that the testers are unable to determine